Alright, y'all. Here's some help going through these homework questions. Um, Again, what we're going to do here is first we're going to start off doing this solving graphically, then we'll go over here and solve algebraically. What you have to do is we have to graph f of x, then we're going to graph g of x. I'll put that in a different color. We'll see where they intersect, and that'll show us what we need to end up with algebraically. So the graph of f of x, I'm going to take my time on this first one. F of x equals the absolute value of x minus 2. So this takes us back to unit 1. This is a linear absolute value graph. The translation of x minus 2 is telling us to go to the right 2. So we go from 0, 0, we go right 2. There's our vertex. I'll put further vertex. Okay, this is an absolute value graph. Again, to finish this off, we look at what's in front. That's our slope. In that case, since there's nothing there, there's actually a 1 telling us the slope is 1 over 1, telling us to go rise 1, run 1. That finishes off our graph. We go up 1, left 1, up 1, right 1, up 1, left 1. That gives us our v. So it looks something like this. Okay, that's our absolute value graph. Now it might have been strategic for us to graph the vertical or that horizontal line first. Just so then we knew how far to go there. I would recommend using a straight edge while you're graphing these so you don't end up getting something wonky like that. But that's our absolute value graph. For our next graph, we have this g of x equals 3. G of x equals 3 is the same as this y equals 3 because g of x and y are essentially interchangeable. What y equals 3 is it's a horizontal line at 3. So we just go up to 3, 1, 2, 3, that's like right here. And we're going to draw a horizontal line along that value of 3, giving us something that looks like that. Now again, as long as you make your points accurate, and we know that we have to go up to 3, it'll be obvious where these two lines intersect. Right, these two graphs intersect at these two like critical points right here, and here, which is happening at x equals, that's at x equals negative 1, and x equals, what is that? 1, 2, 3, 4, 5. X equals 5. Again, I don't want the coordinate points of those yellow circle points. I just want the x values. Only use x values. So it's at x equals negative 1 or x equals 5. Now you could either write it as x equals negative 1 or x equals 5, or you could write it in this brace like that. Now we're going to go over here and solve it algebraically so you can see how it lines up with the algebra. When you're solving algebraically, all you need to do is set f of x equal to g of x. So absolute value of x minus 2 equals 3. And they've already have that set up for us. I'm just going to bring it down so we can work with it. Our steps for solving absolute values, right? We always start with isolate the absolute value, and we look, is the absolute value by itself? Yeah. There's no 2 in front, there's no plus 6 at the end. So yeah, in this case, our absolute value is already by itself. We don't have to do anything there. Let me get rid of that stuff. Okay. Oops, I'm stuck in eraser mode. So now we can solve. Hello? Solve. Let me write. There we go. We can solve this algebraically. How we solve this algebraically is we have the absolute value by itself. Now, to get rid of the absolute value, we can set up two different equations, right? Because it's an absolute value, we set up x minus 2 equals positive 3, or x minus 2 equals negative 3, right? Because an absolute value can be positive or it can be negative. We solve these individually. Plus 2, x equals 5, or plus 2 over here, x equals negative 1, giving us x equals 5 or x equals negative 1, which is exactly what we got on that graph as well. Again, you can write your answer as x equals, this is a brace of 5. Well, let's write the negative first just to stay consistent here. Sorry. -1, or 5. Geez, I messed up that brace pretty bad there. Let me fix it. My apologies. There we go. Now both of these work as answers. You can choose. These mean the same thing there. But that finishes off that first question. Okay, so here's some help on number 2 here. Again, I'm going to go through a little bit quicker as we get farther into this, assuming that you're okay with this first part. All right, so we start off by graphing f of x. Let me pull that off to the side. F of x equals 2 absolute value of x plus 3. And we're also going to graph g of x. Now, it might be to our benefit to graph g of x first, because that's going to tell us kind of how high to go or how low to go for our graph. So I'm going to start with g of x equals 2. Again, that's just the equation y equals 2, which is a horizontal line at 2. Okay, so that's where our g of x is. Let me label that. Our f of x, that's this absolute value function here. Again, that's linear absolute value. We can go through our steps back from unit 1. X plus 3 is telling us to go left 3. There's nothing added on to the end, so we just go left 3 for that vertex. Let's go left 1, 2, 3. There's our vertex, and to finish this off, we look at that number sitting in front. That's our slope. 2/1 telling us to go up 2 to the right 1. So we're going to go up 2, right 1. That puts us here, up 2, left 1. Now, why we did g of x first is because now we don't need to keep going up 2, right 1, up 2, left 1. We could if we really wanted to, but let's just stop at that g of x line because we know we don't need to go any further than that. That's kind of the important pieces that we need. We can draw our absolute value graph now. Something like that. Again, what we're saying is, where do these two functions equal each other, right? Where they intersect. Again, that intersection point, or those intersection points are right here. And we are just looking at their x values, right? We just want the x values for those problems, for these problems, and that's at what? X equals -2 and x equals, what is that, -4? So -2, let me stay consistent here, -4 and -2, we'll just write the lowest one first, though it does not matter, saying that we have x values at -4 or x equals -2. Okay, you can write it like this, or you can write it in a brace like we did up top. Again, now we'll pop over here and solve that same exact equation algebraically to show you that it matches up. So now this is kind of set up a little bit differently, not exactly the same. It says solve algebraically for x, f of x equals 2. They already have the equals 2 done. We know that f of x from this beginning problem is 2 absolute value x plus 3 equals 2, and we can solve that. Right now, our first step is to isolate the absolute value. In this case, we need to move this 2 that's sitting out in front. To move that 2, think of it as just, what if it was like 2x equals 2? To move that 2 in front, we divide both sides by 2. So we're going to take that same step here, divide both sides by 2. That'll isolate our absolute value. These 2's reduce with each other, cancel out, and we're left with absolute value of x plus 3 equals 2 divided by 2 is 1. Now we have isolated our absolute value, and to get rid of the absolute value, this is when we break it into our two different equations. The first one is x plus 3 equals +1, or still x plus 3, but now it equals -1. Those are our two equations. We should be able to solve those. Simple one-step equation. Subtract 3 from both sides. X equals 1 minus 3 is -2. Or subtract 3 from both sides again. X equals -1 minus 3 is -4, giving us our two answers there, -2 and -4, which again matches up perfectly with our answers from our graph. And again, we can just state those in a brace as well. These mean the same thing. It's really whichever way you feel comfortable with. That finishes off that second example for us. All right, here we go again. I'm going to move a little bit quicker through this graphing part so we can look at the algebraically, but we start with graphing each piece at a time. We start with that f of x equals 3, absolute value of x minus 4, and g of x equals negative 2. Again, it's probably beneficial for us to graph that constant first, just because it's going to tell us how far to go for our graph. So that's at y equals negative 2. That's a horizontal line down 2. So we end up right here. Horizontal line down at 2. That's g of x. Now let's graph f of x. We look at f of x. This is a linear absolute value. Again, it's a v. That's all we're dealing with here. X minus 4 is telling us to go to the right for the vertex. So let's just go from 0, 0 to the right. 1, 2, 3, 4. Puts us right here. That's our vertex. And to finish this off, we look at what's the slope. The slope is that number sitting out in front. In this case, it's 3 over 1, telling us we go from that vertex, we go up 3, right 1. Up 3, left 1. Now notice how we can keep going up 3, left 1, up 3, right 1. We're not getting any closer to that line, which is interesting because the point of these problems is to see where do these graphs intersect. In this case, they don't, right? We don't have any place where these two graphs are intersecting, so I guess that's no solution, right? So I'm just going to put no solution for the graph. Now let's look at what that will look like algebraically for us. So we're going to pop over here for the algebraically part, for part B, and we're going to start by setting f of x equals g of x. F of x is that 3 absolute value, x minus 4 equals g of x is negative 2. Okay, let's go through our steps, right? First step is to get that absolute value by itself. We can't have the 3 in front of the absolute value of x minus 4. To move it, we divide both sides by 3. Okay, divide by 3, divide by 3. Absolute value of x minus 4 equals negative 2 over 3. And we can't go any further. We have to stop right here. Why is that telling us it's no solution? That's strange. Well, the reason is, anytime we take an absolute value, right? If it's absolute value of positive 2, it's positive 2. If it's an absolute value of negative 3, it's positive 3. If it's an absolute value of negative 6, it's positive 6. What keeps happening here? All of these end up being positive, right? There's no case ever where we can do an absolute value when it's isolated and get a negative number, right? There's no way we can take an absolute value of a number and get something negative on the other side, telling us that there's absolutely no solution to this problem. All right, so I'm going to put no solution. Absolute values, if you want to think of it, absolute values will always give us a positive number, some positive number over here. And this is saying there's a positive number and it equals negative 2/3. That's impossible, telling us this is no solution. Anytime you have isolated the absolute value and it's a negative on the other side, stop. It's a special case. Specifically, this is no solution. And this is what's showing us graphically why it's no solution there. Alright, so here's the last one of these graphing and algebraically problems here. Again, we start off by graphing f of x and g of x. Just make sure you don't forget any of these little pieces on the equations. And let's get in the habit of graphing that constant first, because it kind of makes it so we don't have to do as much work when we're graphing the absolute value. So, and g of x is negative 1. When I say constant, I'm talking about the horizontal line. Right, so in this case, y equals negative 1 here, which is this line. It's because it's going to limit how far we do our graph, and there's no point in us putting a whole bunch of points kind of blindly there. Okay, so we graph f of x. F of x is, again, it's a linear absolute value, just as it's been for all of these problems. X plus 2 is telling us to go to the left 2. That minus 1 is telling us to go down 1 for the vertex. Okay, so we're going to go left 2, down 1. There's our vertex, and it's right there on that right there on that constant, which is pretty interesting. To finish this graph off, we're going to use that -1/2. That's our slope. Again, that's our rise over our run. So we go from that vertex, we're going to go down 1 to the right 2, down 1 to the left 2. We don't really need to extend that any further because we already have this point of intersection. That's the biggest point on these graphs, is we just want to see where they equal each other. Hence, we just want to see where is this intersection happening. And in this case, it's only happening at one point. And that's absolutely okay. We do not always have to have two different answers there. So if I can find my cursor here, sorry, we'll pop down here and we're going to say that's happening at what, x equals -2. So that's our answer, right? X equals -2. Now let's look at it algebraically so you can see why this happens and when these special cases will pop up. Again, we're going to set f of x equal to g of x. F of x is that absolute value function, so that -1/2. Here, let me use a different color. Sorry. That -1/2 absolute value of x plus 2 minus 1 equals -1. Looking at that, there's no way we can be like, oh yeah, there's definitely going to be one solution, right? But what we have to do is go through our steps, right? Get the absolute value by itself. We can't have this -1/2 out front. We can't have this -1 at the end, so we have to move them. To move that -1, we're going to add 1 to both sides, and watch what happens. Right, -1/2 is still out in front. Absolute value of x plus 2. -1 plus 1 is 0. Oh, that's interesting. Okay. We still have to do one more step here. We have to get that absolute value completely by itself, which means we have to move that -1/2. If you weren't in class, the way we moved that -1/2 out in front is instead of dividing by -1/2, which we could absolutely do, dividing by 1/2 is the same as multiplying by its reciprocal, which means we're just going to take 1/2 and flip it upside down. That's the reciprocal, so we multiply both sides by -2/1. That's anytime you have that fraction out in front. That cancels out our fraction. We're left with just the absolute value of x plus 2 equals 0 times 2, or -2/1 is still going to be 0. Okay. Now we're at this point where we can solve for x, right? To solve for x, we set up our two equations. So we break it up, right? X plus 2 equals 0, or x plus 2 equals -0. Is that a thing? Is there a +0 and a -0? No, 0 is the one number that's neither, we can't count it as a positive or a negative. So that's why we're only ending up with one solution over here, like we have on the graph, right? Because if we solve this, subtract 2, x equals -2, or subtract 2, -0 minus 2 is still going to be -2. We end up with the same exact answer on both of them, telling us that we just need x equals -2. Which is good. That matches up with our graph over there. So anytime we have this absolute value, you've isolated it, it's equal to 0, you don't even have to set up that right-hand side, right? There's no +0 and -0. Just set up the x plus 2 equals 0. Save yourself a little bit of time there by doing that. But that finishes off those first 4 problems for you.
So here's number 8 from that worksheet. Again, what we have here is this f of g of x. That right there, that like thing that looks like fog, that's the same as this, f of g of x, which is the function, which is the composition of functions, and we have set that up. So let's set that up first. So I'm just going to go off to the side and set up f of g of x. Right, remember when we're setting this up, we already have that f of x is over here. It's absolute value of x. G of x is that 2x minus 5. So what we have to do there is take whatever is inside, whichever function's inside, so which is in this case g of x, so that 2x minus 5, and we're going to take it and substitute it in for x in f, because f is on the outside. So really what we're doing here is an intermediate step. I would not recommend writing this anymore just to save you some time. We're just replacing x with 2x minus 5 in this function, so we end up with absolute value of 2x minus 5. Again, wherever that x was, we just replaced it with 2x minus 5. That is f of g of x. Okay, so now we're going to take this and we're going to substitute that in to this equation over here for f of g of x. So we end up with 3. We just found that f of g of x is the absolute value of 2x minus 5 equals 0. And from this point, we're solving an absolute value equation. Again, what we want to do is we need to isolate that absolute value. So I'm going to isolate, whoops, sorry, that's supposed to be a absolute value sign. Oh, I'm trying to get my pen here. Isolate that absolute value of 2x minus 5, which means we need to move this 3 that's sitting right there in front. To move that 3, we divide both sides by 3. Those cancel out with each other. We're left with absolute value of 2x minus 5 equals 0 divided by 3 is 0. And here is when we have one of those special cases where we do need to break it up. We have to get rid of our absolute value, so we split it into two equations. 2x minus 5 equals 0, or 2x minus 5 equals negative 0. Again, we don't actually have to do that negative 0 case. There's no positive and negative 0, so we really just have to set up 2x minus 5 equals 0. Now I'll leave that minus equals negative 0 just so you remember that you do have to set up two equations. It's just when you're solving here, you're just going to end up with one answer. So we get 2x equals 5 and x equals 5 over 2. That is your single answer. Make sure that you're going through and you just leave it as a fraction there. The last thing that it wants us to do is graph it on the number line. On a number line, it literally is just you have your number line here. Put a line for 5 over 2. And to say there's an answer there, you just fill in a point right there saying, yep, there's an answer. It's at 5 over 2. That finishes off number 8 for you there. Okay, so number 9 here, again, what we want to do is we want to solve this absolute value function. Now, the first thing is this is a trap at first. You see this, there's a negative on the other side, immediately you want to be like, oh, that's easy, no solution. But we can't jump to that conclusion, not yet. What you have to do on all of these problems is start by isolating that absolute value. We have to get this by itself first, then we can make any decisions that we want from there. So to get this absolute value by itself, we divide both sides by negative 2. Divide by negative 2. Those reduce out. We're left with the absolute value of 1/2 x plus 4 equals negative 12 divided by negative 2 is positive 6. So in the end, this ends up being a positive number, which means it's not no solution. We can go ahead and go on to that next step here. That next step is we need to set up two equations. That's how we get rid of the absolute value, right? The first equation is the positive case. 1/2 x plus 4 equals positive 6. Or the other case, that's our negative case, right? So it's still 1/2 x plus 4. That doesn't change. The only thing that changes is that becomes a negative 6. Now we're just going to go through and solve each of those equations by themselves. We start by subtracting 4. We get 1/2 x equals 6 minus 4 is 2. And then this is very similar to what we did in the notes. To get rid of that 1/2 x, we could, in theory, divide by 1/2. That's fine if you're able to think of how many 1/2s are in two holes and get 4. If you're not able to think about that, the easy little trick here is to get rid of that 1/2, we can multiply by its reciprocal, which is 2 over 1. So if we just multiply both sides by 2 over 1, that also gets rid of the 1/2, leaving us with x equals 2 times 2 over 1 is 4 over 1, which is just 4. Okay, so that solves the first piece. Now let's go look at that negative case. The negative case, you'll realize, is the same steps. We still subtract 4 first. We get 1/2 x. Negative 6 minus 4 now is negative 10. And again, at this step right here, to move that 1/2, let's just multiply by the reciprocal. So we're going to multiply both sides by 2/1, leaving that fraction to reduce out with itself. We're left with just x over here equals -10 times 2 is -20/1. X equals -20. So we end up with those two answers. Again, you need to write it when you have two answers as this, x equals 4 or x equals -20, or the other way you can write your answer, and it's totally okay if you choose. I don't want to put too many ors because I don't want you thinking they're all the same answer. The other way you can write it is like this. X equals, it's a brace 4 and then -20. That's the same as saying x equals 4 or x equals -20. Choose one of those ways of writing it. Either way works for me. Just do whatever you feel comfortable with. But that finishes up number 9 for us. Just be careful. Don't try to assume at the very beginning that, oh, since that's a negative out in front or at the end, that means that it's no solution. No, make sure you get the absolute value by itself first. Then you can say it's no solution or not. In this case, we could solve it. Okay, so here's another problem where they have this function notation. The first thing we're going to do is just go through and remind you that f of g of x looking like this, these are the same, right? That's just saying f of g of x, where this is saying the same exact thing. Let's just go off to the side and set that up. F of g of x. Again, you're looking at which function is inside. We have that f of x is equal to the absolute value of x. Oops. G of x is equal to 3x minus 6. G of x is on the inside, so we take whatever that is, 3x minus 6, and substitute it in. So f of g of x is equal to the absolute value of 3x minus 6. That's the first step there. So all we're going to do is take that and substitute it into our equation for f of g of x. Okay, now let me rewrite the equation. We still have 7 minus 3 f of g of x equals -14. So we go 7 minus 3. F of g of x we just found was absolute value of 3x minus 6 equals -14. Now we're set up with like some of those problems that we just went through. We're going to solve that for the absolute value. So we isolate the 3x minus 6, the absolute value. I'll put isolate absolute value of 3x minus 6. So we start by subtracting 7 on the outside. We're left with -3. Absolute value of 3x minus 6. -14 minus 7 is -21. And then to get that absolute value by itself, we're going to divide both sides by -3. Giving us absolute value of 3x minus 6 equals +7. We end up with +7, meaning we can go ahead and set up those two equations. We go positive case, 3x minus 6 equals +7. Negative case, 3x minus 6 equals -7. Again, it's still 3x minus 6 on both of them. All that changes is the 7, and you solve those separately. Add 6. 3x equals, what is that, 13, divide by 3. So x equals 13 over 3. Or, we solve that one on the right, same steps. Add 6. 3x equals -7 plus 6 is -1. Divide by 3. X equals -1/3. So that would be your answer there. X equals 13 over 3, or x equals -1/3. The other way you could write it, again, there's the second way of writing your answers. You could choose to write it like this. X equals, with the brace, 13 over 3, -1/3. Those are the same answers. Choose which one you want. And then to finish this off, we're going to represent our answer on a number line. So you just draw your number line. Doesn't have to be perfect. Make sure you have a line for 13 over 3, a line for -1 over 3. The only thing there is make sure the positive number is on the right side of the negative number. You just put points there to say where they're at. And that finishes off number 13 for us. Again, All that changes there is you have to set up this f of g of x first, which we just went off to the side and did. Then it becomes just like the problems that we've been working through. All right, so this is the last problem we're looking at here. Again, what we're going to do, this is set up for us so we can just go into solving. So we're going to isolate the absolute value, which is in this case 4x plus 7. So we're isolating this. To isolate that, we start by subtracting 5 from both sides. Subtract 5, we're left with this positive 2 out in front. Absolute value of 4x plus 7 equals 1 minus 5 is negative 4. Okay, now to move this 2, we divide both sides by positive 2, leaving us with the absolute value of 4x plus 7 equals negative 4 divided by 2 is negative 2. We are officially done with the problem. You have isolated this absolute value, right? We don't have anything else to do, and we're going to stop right here. Right? This is a special case. You have the absolute value by itself. Absolute values cannot equal negatives, so this is actually no solution. Again, I'm going to say absolute value cannot equal a negative. That is after you have isolated it, though. You need to isolate. I'll put isolated. Absolute values cannot equal a negative, right? Reason being, you can never take an absolute value of a number and get a negative number, right? Absolute value of 2 is positive 2, absolute value of negative 2 is positive 2. There's no way we can do an absolute value here and get a negative 2. So basically the easiest way to think of this is anytime you do the absolute value, it's a positive. This is saying there's a positive, it's equal to a negative 2? No. That's impossible, hence no solution. And that finishes off your examples there. If you have any other questions, please let me know.